Good morning, everybody. This is a live extreme weather briefing on the bomb cyclone that's going to be happening off the East Coast. Whether it does impact land or not, but now confidence is increasing on that swath of snow. Looks like the max is going to be just to the southeast of Boston, down through Cape Cod. And Martha's Vineyard even getting in on the action. Looks like the eastern tip of Long Island and maybe down toward far southeastern New Jersey, even southern Delmarva Peninsula. I'm showing you the Zero-Z European model from last night. We did have a little bit of noise last night in the NAM model and the GFS and the Zero-Z, showing a little bit more progressive of a system, a less amplified 500 millibar vort upon arrival on the East Coast. And even the NAM model showed that snowband missing southern New England completely, but it does look like the GFS and the NAM model underestimated the height of the ridge just behind the shortwave that is now diving through the western U.S. And I have to admit, I am not an expert on forecasting these snowstorms and synoptics. I'm more focused on the smaller scale, severe weather, tornadoes, storm systems like that. But I do give a strong effort on forecasting, and I do look at the models in great detail. I do follow a lot of the experts too, that are comparing each of the model initializations with those RAYOB, the actual observations that are coming in the upper levels of the atmosphere across the western U.S. Jack Sillen is one of the brightest minds, up-and-coming meteorologist that really breaks down all of the data. And so far this morning, he noticed that the GFS and the NAM model may have been underestimating the amplitude of the ridge back behind that shortwave that is diving through the western U.S., helping to support the European model solution, which seems to have more run-to-run consistency as well, a lot more stability within that model run compared to the NAM and GFS that have just been all over the place leading up to this event. But it all depends on the amplitude of the 500 millibar vort upon arrival on the East Coast, how deep, how potent that upper level system is. If it has a little bit of a slight negative tilt to that system, that'll make all the difference on how quickly this bomb cyclone develops, matures, and how close to the coast that it travels. The Zero-Z European model from last night, there you can see that surface low track, even meandering a little bit, doing that little bend, the shimmy off to the left that it does just beyond Cape Cod. Does look like blizzard conditions, so those northerly winds are going to be ripping down through areas like Cape Cod. Boston could get 10 to 16 inches of snow as well. But the snow max, the area with 2 feet and greater, looks like it's going to set up just to the southeast of the Boston area. Maybe out near Plymouth Rock would be a great place to cover this blizzard. I do think there's also going to be thunder snow potential with that convective warm conveyor belt hammering the coast just ahead of this low pressure system. And as I mentioned, the threat for New York City and a little bit further west all depends on the amplitude of that 500 millibar vort upon arrival on the East Coast. This is the European solution that shows that deeper wave arriving on the Carolinas, and it's not that much deeper than the other models, but just very subtle differences in the shape of that 500 millibar vort can play all the difference with the evolution of the system off the East Coast. And right now, that shortwave is over the continental U.S. It is over the western U.S. right now, bringing with it some snow over portions of the Mountain West, including areas like the mountains of Utah and eventually into Colorado as well. Maybe 1 to 3 inches or so in the Denver area as that vort arrives. But keep in mind that the GFS does seem to be underdoing the amplitude of the system as it arrives on the East Coast, and it also is underdoing the height of the ridge back behind that system, which is giving clues that the European model might be the more accurate. And when you look at run-to-run consistency, it does seem like the European model is a lot more stable and just has a better handle on that cleaner trough ejection, the cleaner phasing, as well with that short wave that it's dragging across the southern U.S. If it does have a clean phasing with that southern lobe of vorticity, then it'll have a greater likelihood of attaining that deeper amplitude and that slight positive tilt just as it ejects off of the mid-Atlantic. And here I am showing you the European from last night from Zero-Z. And now I'm going to do a little bit of a model comparison here on the pivotalweather.com website. We'll just do a bit of a model comparison, the initializations as well, to see the differences between these two solutions. I do think that once the 12Z models come out, that we're going to see a majority of these models converge toward that European model solution from last night. The Zero-Z models with that cleaner trough ejection the slightly deeper, higher amplitude of this wave as it arrives on the East Coast. So here is the GFS model, and watch the height contours with this ridge back behind the system. Here is your shortwave trough that is diving off to the south and east. And this is the European model. There's the trough Thursday. Later on this afternoon, it's going to be diving down through the Four Corners region. That's the GFS model. There is the European model. So you can see the height contours back with this ridge back over the western Canada, Pacific Northwest region. Watch as I toggle between the GFS, which is the American model, and the European model. See how the European has that higher ridge off over the western U.S.? And watching some of the experts online, it appears that the European model is more in line with this morning with those height contours. That's later on this afternoon. So this is this morning right now. You can see this ridge building in behind this short wave. So if you have a larger ridge over the western U.S. and western Canada, it likely means that this system is going to be higher amplitude and more potent as it rounds the southern U.S. and eventually arrives on the East Coast. That's your GFS model. There is the European model. So see how it has a slightly flatter ridge back behind it? And you can watch that 567 decameter height contour as you go from the European and then back over to the GFS model. Watch the 570 especially. Good heavens. So it does seem like the European has a larger ridge back behind this shortwave trough. And even though when you compare the actual shortwave trough between these two models, they appear that they're the same amplitude right now as they're diving south into the Mountain West Four Corners region. But really the difference is in this ridge right in the backside behind it. Jack Sillen is a master at seeing which models are doing well, comparing to the actual observations at the upper levels as well, and then making an assessment of which model has a better handle on these. So this is by Friday morning at 12Z. This is the parent shortwave that's diving off to the southeast, down in the Corn Belt area, centered over about Davenport, a little bit to the southeast of Davenport across northern Illinois, and it's going to be dragging this lobe of vorticity back behind it. So just how cleanly do these two lobes phase? You have the southern stream down here, you have a suppressed subtropical jet due to La Nina as well. Maybe could allow for a cleaner phasing as well, using a little bit of that climate, the La Nina, year 2 La Nina, and that suppressed subtropical jet to lead to a more clean phasing between this trough diving south through the Great Lakes, southern lobe of vorticity on the south side. So you can see that this storm, this trough axis is trying to gain a neutral tilt on approach to the East Coast by Friday afternoon. And how high is the amplitude of the system? We're looking at the GFS. So there you can see the European model. There's the GFS. The European model is a little bit slower, a little bit higher amplitude, and a lot of it is because of this ridge back behind it as well, or at least that's an association. I'm not making any claims on causation with this, but you could definitely see the difference in the shape of that trough. The European, just a little bit slower, but deeper. You can see that that little trough axis is trying to gain that negative tilt a lot more so within the European model. And it does seem like it's a lot more of a stable model as well. So there's the GFS solution. There's your European. And this is last night's 0Z model. And the GFS from last night actually has the snowband missing the southern New England. Almost missing it. It grazes the tip of Cape Cod out there. Hammers Frankie McDonald out in Nova Scotia. And that's because of this faster, lower amplitude wave as it's reaching the East Coast. A little bit slower of an evolution to that negative tilt as compared to the European model. There you can see the GFS shape of that short wave. There you can see the European shape to that short wave. And those are the differences between the different models and the NAM as well. Interesting, kind of a flat trough. This is the 0Z NAM last night that brought that snow a little bit closer to New England. So it did seem like from 18Z to 0Z, the NAM morphed a little bit closer to the European model. But boy, does that look like a flatter, not a flatter, but higher amplitude, but a more narrow in the west to east direction. The NAM has been quite noisy, though, as we've led up to this system. That run-to-run stability seems maximized with the European model solution. And look at that negative tilt with the short wave. cleaner phasing with that southern shortwave, and this helps to gain this system, that negative tilt, helps to decouple the jet maxima. You have the jet maxima around that growing ridge upstream of that bomb cyclone. You also have the jet maxima rounding the base that's more associated with that southern lobe of vorticity, helping to gain that negative tilt. And then you get the favorable co-location of the 300 millibar jet entrance and exit. So here is the jet entrance region. Here's the jet exit. This is your jet max. This is your jet max on the north side. Decoupled jet maxima, but coupled jet entrance and exit regions. The left exit region is associated with rising motion in the mid and upper levels of the atmosphere, and the right entrance region is also associated with rising. That's because of the diverging ageostrophic flow. You have accelerating flow in your U direction, which in this case is what will make that parallel to the jet streak. So then the ageostrophic flow, when that is a positive, points upward. So your ageostrophic wind, which is basically a wind that's directed opposite of the geostrophic wind, but you get ageostrophic difluence aloft associated with the right entrance region of that jet and the left exit. And when they're co-located or coupled, that's when that difluence is maximized over the western gradient of the Gulf Stream. The Gulf Stream is also about 5 to 10 degrees above normal right now for this time of year across the Atlantic, just off of New England. That could help to aid that warm conveyor belt, aid in those positive feedbacks, the building of this ridge upstream of that warm advection, upstream of that bomb cyclone with that warm conveyor belt. A lot of latent heat release also that happens. But it's key to get this negative tilt with that vort. And then you can drill down to the surface, and you can see exactly where that bomb cyclone is forming, right near where that coupled jet maxima is located. And now you can look at the different surface flow tracks between the 0Z model. Still discrepancies. There's the GFS, further off to the east, progressive, lower amplitude wave. That brings the snow offshore, just grazes Cape Cod. And then you go back to the European model, further west track, hammers Cape Cod with a blizzard. Snow max right over Cape Cod as well, just southeast of Boston. Boston getting 10 to 12 inches of snow. Looking at your NAM model, 0Z NAM last night, morphed closer to the European model after that 18Z model run that showed that snow band well offshore. So I think that many of these models that are having trouble with consistency run to run are having trouble resolving the positive feedbacks and the convective feedbacks that happen with a bomb cyclone, a negative tilt charging into that warm Gulf Stream, the 5 to 10 degrees above normal with those sea surface temperatures out in the Gulf Stream. I'm going to side with the model that seems to be handling those positive feedbacks and nonlinearities a lot better, and it does seem to be the European model, also supported by a more accurate resolution of that ridge back behind the shortwave that is now diving through the Mountain West. So it does look like this is going to be a blizzard, and a big one. Southeast of Boston, down into Cape Cod. Looks like I'm going to be having to head in that direction tomorrow on Friday. By Saturday morning, though, this thing is going to be absolutely hammering Cape Cod. Looking at that European model there again is the GFS going back and forth between the 0Z GFS last night and the European. It's going to be a bomb cyclone over the ocean. It's just how close does that surface low meander to southern New England, which will determine just how severe this blizzard is going to be. Whether it's going to be a grazing impact out on Cape Cod, or is it going to hammer Cape Cod and all of eastern Massachusetts, down East Maine as well. So those are the answers that are going to be answered during the day today. But I do believe in that European model snow map. There you can see the European model, that swath of snow. Snowfall probably exceeding a couple of feet in that zone just to the southeast of Boston. It does look like Plymouth is going to be the place to intercept this snowstorm with that unimpeded wind just ripping off the Atlantic. There, the northerlies across Cape Cod, that's going to create whiteout conditions. We're probably going to see thunder snow as well in the middle of that convective warm conveyor belt that's just going to be hammering this area. Let me go back to the models and show you that warm conveyor belt. And the winds, too. I want to show you some of the winds here. I do think we're going to see a blizzard We'll do the 10 meter above ground level wind gusts starting Friday at 15Z. Let me go back to the single image as well. And we'll go to the European, 0Z European last night. So here are those wind gusts. And this is also what I plan to be covering. Blizzard conditions, whiteouts. We'll step forward in the European model. That's at Friday morning. This is Friday about midday. Friday afternoon, you start to get that wind beginning to increase off of Delmarva. Friday evening. And then in the overnight hours, this is at 6Z, midnight Friday. Wind really starting to rip along the New Jersey coastline and along the coastline of Delmarva. Not quite starting yet across Cape Cod, but look at Long Island, southern coast of Long Island. Those northeasterly winds are going to be ramping up. This is midnight Friday night. Whoa! Saturday morning as the cyclone is bombing out over just due south of Long Island. Look at these winds ripping. The orange there is greater than 60 knots. That dark yellow color, the yellow-brown there, that's greater than 60 knots. Winds really starting to crank off of Cape Cod. 55 there just to the north of Boston. And just that whole coastline in yellow, which is pushing 50 knots by Saturday morning. That's 7 a.m. on Saturday morning. Cape Cod gets completely dominated there. 60-knot winds over Cape Cod, eastern Massachusetts, and over the eastern tip of Long Island. That's the middle of the day on Saturday, about 18Z. Blizzard continuing to crank by Saturday evening, especially out on eastern Mass and Cape Cod with that orange 60-knot plus winds, eastern Mass. And then those 50 to 60-knot winds arrive across down East Maine. The coastline of Maine is going to get hammered by this system Saturday evening. Northerly still just ripping the northern coast of the Cape there and across the Cape. Lower elevations across the Cape as well. And then down East Maine gets hammered by those 50 to 60-knot winds. And then the winds finally begin to subside by Sunday morning. Moving out by midday. Those winds finally begin to subside. But even by Sunday morning, still 30, 35 knots across eastern Mass. Mount Washington still getting ripped by that big-time wind there Sunday by midday. So it does look like this is going to be a big-time blizzard. That's what I am seeing in the European model. And looks like I'm going to be heading out to cover this event and streaming live during this coverage. Thank you, everybody. Put on your seatbelts. Hold on to your butts. This Bob cyclone is coming to southern New England. Unless the models throw a curveball today. But it looks like the real observations, everything is supporting a higher amplitude trough, digging into the southeastern U.S., gaining that negative tilt, leading to that coupled jet entrance and jet exit structure, decoupled jet maxima, big warm conveyor belt of heat and moisture streaming into southern New England, potential for thunder snow as well. So stay tuned. I'll continue to do these weather reports if there are any curveballs anticipated today. Otherwise, I'm going to be likely heading up to Plymouth Rock to cover this blizzard on Saturday, heading up to get into position on Friday. Never stop chasing.